Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Allahumma a'inni ala zikrika wa shukrika wa husni ibadatik. Iteration. Iteration means numerical solutions of equations. Lecture 1. For this lecture, I am using the work of one of my best student, Miss Sayyida Fiza Kaisar of class 2020, the Lyceum. Comprehensive concepts plus regular practice is equal to A star. An important advice for me and for everyone, always dress properly. Sketches. Reciprocal functions. We have two types of reciprocal functions, functions with odd powers and functions with even powers. This is the reciprocal function with odd power. This function has power 1. We can have any odd number here. We can have 1, 3, 4, 5, anything can be here, and any coefficient can be here, any number can be here, like 2, 3, 4, 5, 1, whatever. But the important thing of this function is this function has power 1 with positive coefficient. This is very important. If you will observe this function, now this function has power 1 with negative coefficient. These are the important things. So, and we can have any power here, any number in power, like 3, 5, any odd number can be here. So when we have reciprocal function with odd power and positive coefficient, then this would be the sketch of that function. And when we have same function with opposite sign, like negative sign here, then this would be the sketch. Basically, the opposite of this sketch, the reflection about y-axis, or you can say the reflection about x-axis. You have to learn these sketches for this chapter, and you have done these sketches in O-level math syllabus D in graphs. For even powers, now see, this function has power 2 with positive coefficient, and we can have any number, any even number can be here, like 2, 4, 6, 8. So this is the sketch of this function. And when we have this function with negative sign, negative coefficient, then we have to reflect this sketch, this graph about x-axis. This will be the sketch of this function. This is parallel to x-axis here and parallel to y-axis here, same is here. Exponential functions. This is e power x. You can write this as y is equal to e power x. I'm sorry. I have mentioned 0 here because nothing is here, and this 0 has has importance. This exponential will be parallel to this number. The exponential, the exponential, any exponential will always be parallel to this number. Like this exponential will be parallel to this number. That is why I mentioned 0 here. This was basically y is equal to e power x, and I wrote this as e power x plus 0. See, the sketch of e power x is this. This is parallel to x-axis over here. This will never meet to x-axis. This is parallel to x-axis. And here, this curve is moving to the infinite. When x tends to infinite, then y will tend to infinite. And this exponential is parallel to this number, 0. Now, we have this exponential minus ex plus 2. What if we don't have plus 2 here? Let's suppose we don't have. What if we have this function? Then this will be the opposite of this function. The sketch of this function will be opposite of this. You have to reflect this sketch about the x-axis. Like this. I'm sorry. This curve is parallel to x-axis over here, and this will reach to infinite. When x will tend to infinite, y will tend to negative infinite. Y will tend to negative infinite. I'm sorry. Now see, whenever you sketch exponential, it's very important you should mention the intercept. This is compulsory. When you will put 0 here, you'll get 1. When you'll put 0 here, you'll get -1. So this is the intercept, the y-intercept. It's compulsory, and please label the axis as well. See, since this exponential has +2 here, so this must be parallel to +2. This has nothing here, so this should be parallel to 0. So this exponential is parallel to 2. And its intercept, when you will put 0 here, you'll get 1, -1. So 2 minus 1 makes 1. So the intercept will be 1. Now let me sketch this correctly, because intercept should be here. Make sure you sketch you make the sketch according to the scale. This is fine, but we should have a proper sketch so that the students will not make the mistakes. This is better because this is 0, 1 and this is 2. You have to learn these sketches. If you will learn this sketch, you can easily learn this sketch. And if you have understood this concept +0 or +2, then this sketch is very simple. This sketch is parallel to 2. This line. This sketch is parallel to 0. Sorry. Next, we did this sketch in differential equations. Y is equal to e power -x plus 5. Now this exponential will be parallel to 5. This is 5. And this number is 6. This is the intercept. And this is fine. And you'll see when x will tend to infinite, this y will approach to 5. And this is we did in differential equations. When x tends to infinite, then this negative power of exponential, like e power -x, will tend to 0. Hence, y will tend to this number. I'm sorry. I'm sorry. -e -x, the opposite of this. So this will be parallel to 0. And this, when you will reflect this curve, what if we had just e -x? So the e -x will be like this. If you will reflect this curve about x-axis, you'll get this curve. Log functions, ln functions. Ln is always parallel to ln x. The domain of ln x is x greater than 0. and ln is always parallel to y-axis. Sorry. Sorry, hi, exactly. Ln is parallel to y-axis because this line has equation x equals to 0 and this is x greater than 0. So this is the sketch of ln x. X greater than 0 and y can take all real values of, any real value. Y can take any value from minus infinite to infinite. This should be like this. Although this is fine, but the proper sketch would be like this. I'm sorry. Uh, Next sketch. This is ln 1 plus 2x. First get the domain of ln because it's very important to sketch ln once we have the domain of ln. So whenever you sketch ln, always get the domain, and this is the way to get the domain of ln because ln is always defined for positive values. So this must be greater than 0. So this is the domain of ln. So this ln will be parallel to minus half. And you must have the intercept as well. Here we had this intercept 1 comma 0. You know how to get this intercept. This is the x-intercept. For that you need to equate y 0, and then this is ln x, and you know the base of ln is e, so e power 0 is x. Anything power 0, answer is 1. So this is the way to get the x-intercept. It's 1 comma 0. Now here you can get the intercept in the same way. You have to equate this y to 0. For ln you have to get the x-intercept. For e you have to get the y-intercept. So e power 0 is 1 plus 2x. So x is 0. So this is the way to get the x-intercept. Quadratic functions. You all know how to sketch quadratic. This is the happy face. And this is the turning point. And minus x square plus 3. How to sketch minus x square? First understand how to sketch minus x square. Minus x square is the opposite of plus x square. This is minus x square. So we have to sketch this minus x square plus 3. So it will be sketched from 3. The intercept is 3. Y-intercept is 3. So this is the sketch of minus x square plus 3. Cubic functions. Positive x cube. This is the way to sketch positive x cube. And this is the way to sketch positive x cube plus 2. It will be sketched from 2. Because this number is 2. When you will put 0 here, you'll get 2. Minus x cube is the opposite of this sketch. You need to reflect this sketch about y-axis. Linear functions. You know how to sketch linear functions. This is very simple. X plus y is equal to 5. This equation has common x and y intercept. This equation, in fact, has same intercepts. So this is 5 and this is 5. You have done this in O levels inequalities. When we have this type of equation, we can easily sketch the line. Same intercepts, 5, 5. Y is equal to x is very simple. You all know how to sketch y is equal to x. It makes 45 degrees from the x-axis and y-axis. Minus x is also very simple. You all know this. We have done trigonometric sketches, sketches of trigonometric functions, cosec, sec, cot in trigonometry. If you want to see these sketches, if you want to understand these sketches in detail, you should watch that lecture. I think it was lecture 4 or 3 or 5 maybe of trigonometry. P3 trigonometry lectures, graphs of trigonometry equations. To refresh the graphs, this is the sine x. You just if you want to sketch cosec, this is the cosec x. You reflect this part of sine from 1, from y is equal to 1, and this is parallel to infinite, and this part is here. This is cos x, and this is the reflection of cos sec x. And cot is the opposite of tan, reciprocal of tan. So tan 45 is 1, so cot 45 is also 1. Tan 0 is 0, therefore cot 0 should be infinite. So this is infinite. And you know how to sketch cot. Steps for iteration. Iteration means numerical solutions of equations. Step 1. Show by sketch that there is only one solution to the equation. We have to sketch these two functions for this domain, and we have to show that there is only one point of intersection. There is only one solution means there must be just one point of intersection of these two graphs for this domain. So this is sec x, and this is 3 minus half x square. This is minus x square. Y is equal to minus x square. Whatever the coefficient is, just leave it. 3 means y-intercept. If you will put 0 here, you'll get 3. So 0, 3 is the y-intercept. This is the complete curve of y is equal to 3 minus half x square. But since we have to sketch according to this domain, that is why I only sketch this part, the right side. See, according to this sketch, there is just one point of intersection. So there is just one solution of this equation for this domain shown. So according to the above sketch, there is only one point of intersection. Hence, there is only one solution of the equation. This is the step number 1. You have to sketch, you have to suppose this y, you have to suppose this y. You have to sketch this separately and this separately for this domain. And this question is of normally 2 marks. Step 2. Show by calculation that the root of f of x lies between a and b. Root means the value of x, the solution, for which f of x is 0. The question is, show by calculation that the root lies between these two numbers. Well, if the root lies between these two numbers, then f of x must change its sign either from positive to negative or from negative to positive. Because to get 0, we must have one negative answer, let's suppose minus 3, and the other positive. Because 0 lies between these two. So if f of x will change its sign either from positive to negative or negative to positive, then the root of this equation must lie between a and b. Therefore, find f of a and f of b and observe their signs. There are two possibilities, this and this. Let's suppose we have this possibility. So, since f of x changes according to this possibility, we can say as f of x changes its sign from positive to negative, so the root of f of x lies between a and b. Example. This equation is given and the question is show that the root of f of x lies between 0.5 and 0.8. So we just need, make sure you use your calculator should be in radian mode. So when you will put 0.5 here, you'll get this answer, and you'll put 0.8 here, you'll get this answer. Since f of x changes its sign from positive to negative, this answer is greater than 0 and this answer is negative, less than 0. Since f of x changes its sign from positive to negative, so the root of f of x lies between 0.5 and 0.8. This is the way to do this step, this part of the question. So step 1 was show by calculation that the root lies between, there is one solution of this equation for this domain. You just need to sketch both the graphs and you just need to show the point of, just one point of intersection. And this is by calculation. They'll give you two numbers like this. In this example, you just need to substitute both the numbers one by one and you just need to observe f of x, the sign of f of x between these two numbers. Step 3. Finding the root of f of x by using the iterative formula. Normally they give the iterative formula. If they don't give the iterative formula, you can make the iterative formula yourself. How? Let's suppose they'll give you this thing, tan x 1 upon 1 plus x square. And now you have to form the iterative formula yourself. How will you form the iterative formula? You just need to make this x subject first. And then write n plus 1 here and n here. Why are we writing n plus 1 here and n here? I'll discuss this over here. So by writing n plus 1 here, we have x n plus 1, 1 plus xn power 2. This is the way to form the iterative formula if the formula is not given. We'll discuss this in detail while solving the questions of iteration. Well, this formula is given right now and the question is find the root of f of x by the iterative formula. And the initial value is also given. Initial value means x1. This is given. When this is not given, then how to suppose this value? I'll discuss this later. Right now, because we are just starting this chapter, so I'm taking this, I'm taking the simplest situation. Formula is given, initial value is given. So this initial value means n is 1. x1 means n1. So when you'll put 1 here, when you substitute 1 here, this will become x2 and this will become x1. So to get the value of x2, you need to substitute 0.5 here. So this will become x2. When you will put 1 here, this will become 1 and this will become x2. So tan inverse 1 upon 1 plus 0.5 square. When you'll check this in calculator, you'll get this answer. Let me substitute this here. When n is 1, this will become, left side will become x2 tan inverse 1 upon 1 plus 0.5 square, because this will become x1. And you can check this answer in your calculator. You have to show the iteration up to 4 decimal places in general. They mentioned in the question. Normally you show up to 4 decimal. Now this is the way to get the value of x2. Now how to get x3? This is so simple. For x3, n should be 2. And for x3, you need to substitute this answer over here. This is x3. Similarly, you can get x4, x5, x6. You have to repeat this process. Repeat the process unless you get a repeated answer or repeated pair. Do this iteration unless you get a repeated number or a repeated pair. Normally you get a repeated number. See, you are getting a repeated number. Here you've got 0.6238, and x10, at x10 you have got 0.6239, and at x11 0.6239. The number is repeating now. This means this formula has converged. Now this formula is giving you same answer from x10 onwards. Whenever you get same answer, that means the formula is converged. And you have to give your answer up to the requirement. The requirement is 2 decimal place. So 2 decimal place is 0.62. See, x10 is this, x11 is this. If you will find x12, it will be same, 0.6293. And it will be same up to infinite. So x10 is same as x11. You can suppose this as x. So xn, if 10 is n, then 11 will be n plus 1, and this x is here. See, if 10 is represented by n, then this will be n plus 1, and this is a x. That means the formula is converged, and that is why we substituted n plus 1 here and n is here. Because when formula is converged, then we write n plus 1 here and n here. This is the logic of writing n plus 1 here and n here. Because in maths, we have to balance the equation. Normally, whatever we do on left side, we do the same thing on right side. So if I'm writing n plus 1 here, I should write n plus 1 here. But this is not according to that logic. This is according to this logic. The formula is converged, so n plus 1 is same. So n is here, n plus is here. This is the way to form the formula as well. Well, repeat the process unless you get a repeated number or repeated pair. Repeated pair means this thing. Maybe you could get this thing, like 1.3281, 1.3283, 1.3281, 1.3283. See, this pair is repeating. This is a pair. So either a number is repeating or a pair is repeating. If a pair is repeating, then take the average of that pair for the final answer. If a number is repeating, just take the number, any number, both are same, up to the requirement. This is the step number 3. And this is the step which you have to do in each and every question of iteration. And this is one of the simplest steps. You just need to substitute this formula into your calculator and then substitute this result to get x2. For x3, substitute this. For x4, substitute this. When you will substitute this in your calculator, you'll get x4. So to get the next number, next answer, substitute the previous answer in your calculator. Iterative formula. I already have discussed this thing. If the formula is not given, then you can form the formula yourself. First, make x the subject. Since the formula is converged, as we know, because when the formula is converged, xn plus 1 is equal to xn plus 1 is equal to x. That is why we wrote n plus 1 here and n here. I already have explained this over here. Step number 4. They will give you 2 different equations and you have to convert the second equation into first equation form. Like this. This is the equation number 1. And the question is, show that the root of the equation 1 also satisfies the equation, this equation. Show that the root of the equation 1 also satisfies this equation. Meaning, the root of this equation also satisfies this equation. So basically, you need to show that both equations are same. Both equations have common root. So always convert this equation into this equation form. Because if this equation and this equation both have common root, that means both equations are same. So by shifting cos inverse here, we have cos x, and after taking the reciprocal of this, we have sec x, and by breaking the LCM, we have this. See, this equation and this both are same. That means this equation is same as this equation. So both equations are same but have expressed in different form. Why are we doing this step? Basically, the examiner wants the answer of this equation, and we cannot solve this equation easily. So he basically factorized this equation into this form, and he will use this equation to get the answer of this equation. We will use this equation to get the answer of this equation. See, we have used this equation here. This is the iterative formula. This equation will convert into iterative formula. We will get the answer of this equation, and once we will get the answer of this equation, this answer will represent the answer of this equation. And initially the question is to find this root of this equation. So indirectly we will solve this equation. We will use, we will form the iterative formula through this equation like this. We will get the answer of this equation, and the answer of this equation will represent the answer of this equation. That's the logic of this step 4. But the simplest way is this: always convert the second equation into first equation form. That's it. This is the way to solve this question. We find root of second equation with the help of the iterative formula, which is the root of first equation. I already have explained this here. Step 5. State an equation satisfied by alpha, the root of the equation. Alpha means the root of the equation. And hence find the exact value of alpha. Whenever you find this type of question, you just need to use iterative formula. Always use this formula. So since it's mentioned, this formula converge means this thing. Like xn is equal to xn plus 1 is equal to x is equal to alpha. So you just need to replace all x by alpha. Whenever they say state an equation satisfied by alpha, alpha means the root of the equation, and hence find the exact value of alpha. Always use this fact. Xn is xn plus 1 is x, and x is alpha. They have mentioned this here. So by replacing all x into this iterative formula by alpha, we have this. Now make alpha the subject. This is the equation, and this is the exact value of alpha. Remember this step. Step number 6. Find the consecutive integers between which the root of the equation lies. You have done this in O-level math, O-level add math. We use trial and error method. Those who are non-add math students who didn't have add math in O-levels, I'm explaining this thing for them especially. Whenever they say find the consecutive integers between which the root of the equation lies, you just need to suppose this as f of x first, and then you just need to use trial and error method. Start with 1. Check 1. You just need to check your answers. You have to repeat the process unless you see the change in sign. So f of 1 is negative 20. Find f of 2 is negative 21. F of 3 is negative 10. See, this is very important. F of x is changing its sign from 3 to 4. Like f of 3 is negative and f of 4 is positive. That means the root of this equation lies between 3 and 4. Since this is negative and this is positive, therefore the required integers are 3 and 4. This is the way to get the required integers, of which the root of f of x lies. Always start with 1. And this is the hint. Use trial and error method. And this is the trial and error method. Step number 7. To show the required equation, use the formula of circular measure. Normally, they give you situation like this. They give you sector. So for sectors, You all know the formulas of arc length and area. You have done this in P1. This is the arc length formula and this is the area formula. Make sure you revise your concepts of circular measure of P1. You have done circular measure in P1. So if you will revise your concepts from there, you can be good at this step. So this is the side angle, side triangle. So what if we need this length? We can use sine theta in this triangle. So if we will use sine theta, we'll get x upon r sine theta upon 2. This entire angle is theta, so half will be, this will be theta upon 2. So AB is this 2x. I mean AB is 2x, therefore we can get the area. It will be half r square sine theta. I mean this is the length of AB. This is the way to get the length of AB. If you need the length of AB, first get x. After getting x, you can get the length of AB. So AB is 2r sine theta upon 2. If you would need this length, for example, if you need perimeter of shaded region, you would need this length. And this is the way to get this length. And you can even use cosine rule as well to get the length of AB. It's your choice. This is the area formula of this triangle. And for right angle triangle, you must know this is r cos theta and this is r sine theta. Adjacent is cos and opposite is r sine. This is the question. I mean this shaded area and information is given also the area of the shaded region is a quarter of the area of semicircle. This area is a quarter of the semicircle. Show that. So area of segment, this segment will be area of sector minus triangle. This is the area of semicircle. It's mentioned. Area of shaded region is a quarter of area of semicircle. So let me correct this. It's all right. Shaded region means segment. This shaded region is also known as the segment. So area of shaded region means area of segment is a quarter of area of semicircle. So this area, how to find this area? This is sector minus triangle. Sector minus triangle. Area of sector, you all know, half r square theta. Area of triangle, half r square sine this angle, pi minus x. And by using, and you know sine pi minus x is positive sine x because it is in second quadrant. This is pi minus x. So this is half r square sine x. And this is half r square pi minus x. You can take half r square common and then you can prove this. So the most important step is this given information. This given information is very important. And this is an important advice for me and for everyone. Speak good or remain silent. I will discuss the important questions of this chapter in my next lecture, inshallah. And after, you should watch this lecture and then that lecture. So after watching this and the next lecture, you will be good at this topic, inshallah. Allah Hafiz.